This is the NAPLAN 2012 non-calculator paper, question 1. The picture shows 5 stacks of coins. So how much money is there in total? Pause the video and attempt the question. Okay, we can see the 5 stacks, 1, 2, 3, 4, 5. But to work out how much money you have, you'll need to count exactly how many coins there are. So we've got 1, 2, 3. These 2 piles at the front, 4, 5, then we've got 6, 7, this pile back here, 8, 9, 10. So we've got 10 coins and each coin is $2, so 10 times $2 is $20. Question 2 of the 2012 non-calculator paper. Helen paid $1.19 for 7 prints at the camera shop. How much did she pay for each print? Pause the video and attempt the question. So it was $1.19 for 7 prints. So to work out the cost of 1 print, you would do $1.19 divided by 7 and do that on your calculator and you will get an answer of 17 cents. 2012 non-calculator paper, question 3. Luke walks to school every day. The distance from his home to school is 1.5 kilometres. Luke leaves home and walks 500 metres towards school. What fraction of the distance to school has he walked? Pause the video and attempt the question. Okay, now I have just drawn a diagram showing that information. So the distance from home to school, H for home, S for school, that distance is 1.5 kilometres and he leaves home, so he leaves from here and walks 500 metres towards school. What fraction of the distance to school has he walked? Now when we first look at this question, we notice that the units are not the same. So we've got metres here and kilometres here. So we really need to change this distance up here and convert it into metres. So we know that 1.5 kilometres is equal to 1.5 times 1,000, which is 1,500 metres. So I'll just put that up there. And I've just shown the working out down here for how to convert 1.5 kilometres to 1,500 metres. So to go from kilometres to metres, metres are smaller than kilometres and kilo means 1,000. So 1.5 kilometres means 1.5 times 1,000 metres. So 1.5 kilometres equals 1.5 times 1,000 metres, which is 1,500 metres. Now to work out the fraction of the distance that to school that he has walked, he's walked 500 metres out of 1,500 metres. So we can write that as a fraction. So we can write 500, this is what he's walked 500 out of 1,500 metres. And then we simplify the fraction. So to simplify that, we can cross off 2 zeros from the numerator and the denominator, so we'll get 5 over 15. And then to simplify 5 over 15, we notice that we can divide both the numerator and the denominator by 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. I can just write that in as well. So I've just shown here how to simplify 5 over 15. I'm dividing the 5 and the 15 both by 5 to get 1/3. You also could have just simplified directly from the 500 over 1,500. If you notice that 500 goes into 1,500 3 times, you can divide both the numerator and the denominator by 500 and you would have immediately got 1/3. So I've just circled 1/3 in there. Question 4 of the 2012 non-calculator paper. Sharon bought 3 fruit buns and 4 bread rolls at the bakery. The buns cost 80 cents each and the rolls cost 40 cents each. How much did Sharon pay? Pause the video and attempt the question. Okay, so she bought 3 fruit buns and they are 80 cents each. To work out the cost of the fruit buns, you would do 3 times 80 cents. And she bought 4 bread rolls at 40 cents each, so you would do 4 times 40 cents. So I'll just put that up here. So we've got 3 times 80, 3 times 80 plus 4 times 40. And remember, this is all in cents, so I'll just put cents there. Okay, now, working that out, 3 times 80 is 240, because you can just do 3 times 8 is 24 and then add a 0. And 4 times 40, to work that out, 4 times 4 is 16 and then we just add a 0. So we get 160 cents. So now we've got 240 cents plus 160 cents. 240 plus 160, that equals 400 cents. And we know that every 100 cents is $1, so 400 cents would be $4. And so the answer is $4. Now NAPLAN 2012 question 5. Joan is making a pattern with sticks. She continues adding sticks as shown. How many sticks will Joan need to make step 6 of her pattern? Pause the video and attempt the question. Now, we can see that in step 1 there are 6 sticks. So we'll just write that down. So step 1 has 6 sticks. If we look at step 2, it has 11 sticks, so that means that 5 sticks must have been added on. So step 2 has 6 plus 5, which is 11 sticks. And we can see that the extra sticks are, I'm just going to go over them now. There's 1, 2, 3, then we've got 4, 5 extra sticks. So step 2 has 11 sticks, step 3 has 16 sticks. So we'll just write that out. Step 3 has 11 plus another 5, which is 16 sticks. And now we can just keep adding 5 sticks for every step. So that means step 4 would have 16 plus 5, which is 21 sticks. Step 5 would have 21 plus 5, which is 26 sticks. And step 6 would have 26 plus 5, which is 31 sticks. And so our answer is 31. Now question 6 of the 2012 non-calculator paper. Which of these designs looks identical after a quarter turn? Pause the video and attempt the question. Okay, now if we look at the first shape, it looks like each quadrant of the shape is identical. So if you rotated it quarter of a turn, then this line would sit on there and that line would then sit on there, etc. So you would actually end up with an identical shape with quarter of a turn. If you tried it with this second shape here, the diagonals, these two diagonals here, would actually be facing in this direction after quarter a turn. So the shape would look different. Again, with this third shape, these two lines are facing that way. If you turned it a quarter of a turn, they'd actually face down this way, so it would not be identical. And with the last shape, if you turned it quarter of a turn, I think these crosses would roughly be up that way. So because this first shape has 4 equal quadrants, then if you turned it a quarter of a turn, you would end up with an identical shape every time. So the first shape is divided into 4 identical sections, so it will look identical after a quarter of a turn. So the only time that the second shape here would look identical would have to be after a half a turn. If it was done half a turn, it would look identical. Same with this third shape. If it was turned half a turn, it would also look identical. And also with the last shape, if it was turned half a turn, so this bit would end up there and that bit here, it would also look identical. Question 7 of the 2012 non-calculator paper. Which expression is equal to 5b cubed? Now 5b cubed means 5 times b cubed, as I've written here. So 5b cubed equals 5 times b cubed. And we know that b cubed means b times b times b. So therefore 5b cubed must equal 5 times b times b times b. And so your answer is the third answer here, 5 times b times b. Question 8 of the 2012 non-calculator paper. This graph shows the price per tonne of crops grown in a country. Now, barley has the little triangle, so it looks to be this bottom one here, and then it goes up there and down there. Wheat has this diamond shape in it, so it's that one there. And the canola has like these square boxes at the top. So for several quarters, the price of barley was greater than the price of wheat. In one of those quarters, the price of canola fell below $500 per tonne. Which quarter was this? Pause the video and attempt the question. Now, let's just read this again. For several quarters, the price of barley was greater than the price of wheat. Now, let's just look at these symbols. Barley has the triangle and wheat has the diamond. So barley is the triangle. It seems to be underneath the wheat at the moment. And just over here, this is where the barley in this section is greater than the price of the wheat. So I'm going to put some little green lines here just to show that from this point forward, the barley is more expensive than the wheat, or it has a greater price. I'm going to put this other green line here to show also from here down. So between these two lines is where the price of the barley is greater than the price of the wheat, because we can see that the barley line is lying above the wheat line. Okay, so here barley is below, then it comes on top here, and then back down here barley with the triangles is below again. So we've marked that on the graph. Now it also said that in one of these quarters here that the price of canola fell below $500 per tonne. So I'm going to put a red line on the graph to show where $500 per tonne is. So it's in one of these quarters between the green lines that the price of canola fell below 500. Now if we look up here, the price of canola with these two squares is above 500, but down here is where the price of canola is below 500. And to me, if I look straight down there, that looks like it is in 2007, quarter 2. So I've just marked this point here and shown the arrow down to show that it's 2007 quarter 2 and circled in the bubble. This is NAPLAN 2012 non-calculator question 9. Rita is drawing the net of this box here, and here is the net down the bottom. Where should Rita put this symbol, this star symbol on the net? This position here, there, or there? Pause the video and attempt the question. Now first we need to identify which faces are which. We have a large, looks like a square or could be a rectangle here, and this rectangular shape here. Now this would be the top of the shape up there, and this big bit down here would be the bottom of the shape. So I'm just going to label those now. So this would be the bottom, this is the top of the shape, okay? And if we look here, this face here seems to be like a trapezium. So that would be this shape here, which is what we can see to be the front of the shape. So this looks like it's the front. So if we've got the front and the top, this bit here must be the side. This other bit, if this is the front and that's the top, this must be the back just here. And this must be another side there. So where should Rita put this symbol? If this is the top and so is this, then the symbol should go on this one, which is on the top. So the symbol is on the top. And so I'll just highlight this box here to show that the symbol should go there.